Welcome. This recording is planned to guide you through using the R software to run a one-way analysis on some results for metabolites measured in the brain area, in a brain area from Alzheimer's disease study. So you will have been provided with these sets of files. One is the data set. There's one that's the R code in a Word document, but you also have that same one in the saved via R. And then another one, if you have time, we might get a chance to look at it, where you can select by column number to do just the analysis on the one column. We'll see what we can get done in our 15-minute time limit of recording. Anyway, you open R. There are instructions for downloading and installing and getting packages and things like that. So if you're missing a package, like in this one, we need the car. We call it up by library car. You'd have to go to find that and get it. Anyway, that's not our purpose right now. What we want to do is set our directory. Okay, I'm on this window here, so my menu up here is functioning for the scripts, and I want to select the console. Then the menu is working for that. So here you can change the directory. So I've already done that. I've changed the directory to this folder that we saw for our exercises. And once you do that, any code will refer to that in this script that I provided. It kind of takes you through that, telling you about set directory and stuff like that. So if I run this one here right now, anything I select in the script window, I can right click and say run. So it shows me over here the directory that I'm set for. When you've selected some text over here as well, you can click on this selection up here to do the same thing as the right click. So the first thing we're going to do is run this line. That's going to help us. It'll take us to that directory to read a .csv file. So you will have to have saved your Excel file, save as a MS CSV file, and I provide you the name of the file here. You saw it in the directory. So when we run this, it's going to open to the directory we're in, and here's the file. So we want to open that. If you wanted to see in R what that looks like, you would just type this new table name. So what we did is we read our CSV file into a table in R called AD. We named it AD, so there it is. There are all of those metabolites and their levels for all the different stages of Alzheimer's disease when we get up here. It's just too many for the screen to hold, but anyway, we'll see more of that later. So that lets you see the table that you just created up here. Now we have to load this library called car. And then what we're going to do is we're going to ask it to how many columns there are in that table. And we need to do that to set it up so we can create a table called AVC with the same number of columns as in the AD. And this just creates a table in which we can generate some results to dump to a file. So what we're going to do next is we're going to create a situation where everything that happens in between this first word sync and the second word sync that would have printed to the screen with this print command will actually print to a buffer and then be saved to a file. The file name is up here after the first sync. And what this for loop is going to do, it's for every column in the total number of columns for that AD table. Now we want to take the names of the columns, right? The I is just all the columns in there, basically, and create a table called columns. And then we're going to run the analysis of variance on that. The first column is called the treatment group. So we want to run every column in AD, that dash I, comma I. So every column from the second one on through. The first one is treatment group. Treatment groups are age-matched control, or control, incipient, moderate, and severe, as we'll see. And the data table, the data is going to be coming from that data table AD. So this is the command to do the analysis of variance. It'll set up a summary, and then those summary tables will be the AVZ. So we'll print our columns. That would go out first. We'll capture it by the sync to send to a file. And then the summary tables for the analysis of variance. This is a one-way analysis of variance. We have one dependent variable, the age and stages of Alzheimer's disease. There's age-matched control, incipient, moderate, and severe. So we have one factor with 4 levels. It's a one-factor, a one-way Anova, or one-way layout. And then we're using Tukey's post hoc test to compare the different treatment groups. And so we're telling it basically to get our data, from the Anova, to run this formula on it, and then dump that to a table called TK. And we're going to print all those to this file called Anova doc. Okay. So let's run our sync. Okay. Now if we go to our folder, there should be a new document in there called Anova Tukeys. I'll just do a read only. Okay, so this is what it generated for all of the 500 or 600 metabolites in that table. There's the name of the metabolite, so we had to print the column name so that would be there. When I first ran this this code, it didn't tell me what the column was, what metabolite was. This is our one-way Anova summary table. We get our treatment groups and our residuals, the degrees of freedom for those, the sum of squares, the mean squares, the F value, and our probability. So this probability is not significant. And so what we're going to continue to do is go through and then filter so that our report only has those that satisfy our threshold p less than 0.05. And then here we have the comparisons, incipient to control, moderate to control, severe, right? So this is the result of the Tukey's post hoc test. We have our differences between the means. Then we have our lower and upper 95% confidence intervals. If you see this is -1 to a +6, so if 0 falls between the lower and upper, it's definitely not going to be significant. And this is the case we have in each comparison here. We have a negative and a positive, so 0 lies in between, so none of these would be significantly different. Okay, but out of all the ones we have, which ones might be? So let's continue through our code, and it's going to pull that out for us. Okay, so now we kind of do the same thing for AD, but we're going to create a new table called AVZ, and we're going to reproduce, replace, when this is generated, it recreates the columns and rows and puts an NA in there because there's no values in the table. We're now going to get rid of those. Oh wait, this is creating that table. So this is a table. So now if I come over here and I type AVZ, and R is case sensitive. So it replicated the number of columns and rows, and we just have NA in there for everything. Okay, so that's going to be repopulated. So now we got another sync here. So we're going to sync this to Anova p-values doc. And for I in AD again, we're going to do the columns and then the summary, the treatment groups. But here we place this condition afterward that for the, starting with the columns in rows 1, essentially here, we're going to just put in that probability column, right? So we're just selecting out the column for probability. So this is still running over here. So now we'll have another document, Anova p-values. And so here's what we pulled out, the name of the metabolite and just the p-value. And then it gave us an NA on there. So now what we've got to do is we want to read that document, and then we're going to set it up so that there's a column called marker and a column called p-values. So we're just going to restructure it into a data file new here, or data frame as it's called, with two columns, marker and the p-value. Right, and then we're going to write that out to a CSV, the p-value table. And we run that. And I need to get the, what was that last time? I forgot the file name. Anova p-values. Yeah. So I need to open that. Okay. So now we should have a new file, p-value table. And this p-value table is this .csv. Notice that we write to a CSV here, and so it'll open right into Excel. And we just got to go into Excel and clean that up a little bit. I didn't know how to write the code for doing this in R, but anyway, if we come in here, we just want to go to the replace, and we want to get rid of that 1 in the brackets. So I already done this before, so it's there. So we replaced 952 of those, and now we want to get rid of this NA. Okay, and then instructed just to save it as with a 2 on the end of it. So just so our records show up there, this is telling us that it's you're going to save it in .csv format, and some things might not be compatible, but we're not worried about that. So now let's go back to R. So we completed that. So open it in Excel, replace, right, with nothing. And now we're going to create a table 3, bringing that 2 file in. Now if I had learned how to run the code all the way through, you wouldn't have to be able to tell it the file names to automatically go and open and everything, especially if I knew how to have R clear up the NA and the ones. But anyway, then what we're going to do is we're going to take from table 3, we're going to look in table 3 for that column of the p-value, and anything less than that we're going to dump it into something called table 4. Did I not close it? I guess nothing showed up as something happened. It's supposed to, some of them were significant. And now we write it out to the one-way Anova p less than. Okay, something went wrong. I know that there are some that are less than 0.5. What happened to us here? Because if we just come in here and we shift end down and down there, oh, I've got the ends in there. I got to replace the n with the replace n with. You see the you may have seen an n in there when I selected things. So if there's something other than a value in here, it won't work. So 0.369, whatever. Replace all those. 415 of them had that. Okay, don't save. Now when we run it, we'll get it. Okay, so just a few seconds left here. So let me open it. 2, open, and then this. We get just a few seconds left here. Run it. And now when we open that, that's not it. A couple of seconds. There it is.